Shall we start? So look at so shall we start?
Yes, sir.
Exercise sheet problem 1. Sheet 1, problem 1. Why this is not more? So problem 1. Okay. What is read the problem. Uh, show that if z is equal to uxy is an integral surface of a vector field V, show that the surface contains the path. Okay, so let us try to see what is given here and what we have to prove. Okay, what is given? Given number 1 that z is equal to uxy is an integral surface a vector field.
Sir, please share the screen.
Screen. Okay. So is it visible now?
No, sir.
Or wait to do this. Now, how is it visible? Whatever I have written today, is it visible?
No, sir.
So you what I have to do? I'm not understanding class mode.
Sir, if your device is a MacBook, you have to give special permissions from the settings, from the preferences of screen sharing
Reference.
for Teams.
Okay. Okay. Now I think okay. Now is it
Yes,
visible?
yes, sir. Yes, sir.
Okay. Okay. So read the problem 1 statement of the problem 1 from the exercise sheet that is given in our home page, course home page. What is write down what is given to us and what we have to prove. The if statement is there. If z is equal to as an integral surface, that is what I am writing it as a given thing. What is given? Given that z is equal to uxy is an integral surface of a vector field V. Vector field V. This is a symbol for vector field V. What is a vector field and what is an integral surface? Just recall what is a vector field. These ABC are A, is a function from R3 to R3 to R. And similarly, B is also a function from R3 to R, and C is also a function. So these are ABC are a functions of X, Y, and U. Okay, and these are several variable function. Several variable function are functions of several variable. So in fact, you can call this as Z also, no problem. So what is a vector field? Vector field is now this is this put together A, B, C. These functions put together is a vector field. So at any given point, if you fix a point x naught, y naught, z naught in R3, we fix a point. So ABC will be again a point in the R3. ABC of this x naught, y naught, z naught, C of x naught, y naught, z naught is again a point belongs to R3 because they are functions, real valued functions. So now a vector field. What is integral surface of a vector field? Whenever this ABC is given to us, that means we are considering a quasi-linear PDE. U, Ux plus B, Uy is equal to Cxy U. Okay. Given or given a quasi-linear PDE implies that is this one, that implies that A, B, C vector field is known to us. Okay. So the starting point is this one. Starting point is we will be given a quasi-linear PDE to solve. Okay. That means this vector field is known to us. Whenever a PDE is known to us, this ABC are known to us. Now, what is here saying that Z is also an integral surface of this vector field. That means we are given a solution to this. Given Z is equal to Uxy, an integral surface. Integral surface of V. That means what? That is a solution. What is the definition of integral surface? If you see the notes, surface. What is the definition? Surface that is tangent at a given point, at any point, to a vector field V is called an integral surface. What is the meaning of this? Tangent at any point. So how are we finding Uy minus 1 is equal to the given PDE implies this is equal to 0. That means what? That means ABC is vector is tangent to tangent to the curve surface. Okay. Now look at the picture of this. How we are finding. Okay. So suppose this is our surface, and P is any point in the surface. Take any point in the surface. So the what is the surface is nothing but it is composition of so many curves. Okay, it is sum total of all the curves, right? All curves put together is a surface. So whenever there is a point and there is a curve passing through this, then what is meant by tangent? Tangent at this point, we are tangent to a surface is nothing but tangent to the curve at that point. So what we are saying is, if this curve has parametric form xt, yt, zt, any curve has a parametric form xt, yt, zt, then the tangent to this curve is represented by x prime t, y prime t, z prime t. That is x dx upon dt is equal to a, dy upon dt is equal to b, and dz upon dt is equal to c. That is the meaning of integral surface. That's how we find that. So these are all definitions, and we had recalled these definitions. Now come to the problem. What is given to us? Yeah, first thing is given to us that Z is an integral surface of vector field. Second given to us is that given a point P, let us say x naught, y naught, z naught in the integral surface.
Sir, excuse me.
Yeah.
Sir, shouldn't the x prime, y prime, z prime be proportional to ABC, not equal to?
Yeah, it's they are collinear. This tangent vector and that tangent vector are collinears, right? They are.
Yes, sir.
Yeah, because see, yeah, I should not confuse with the other thing, characteristic curve. So what we are saying here is that first thing is ABC dot with ux, uy, and -1 is equal to 0. This is the PDE given to us. PDE implies that this is the thing. Okay, what is this? This is a normal vector. Yeah, normal vector to the surface. What is the surface? Surface is
U of xy is equals to u of xy.
that is equal to uxy. This is the surface equation. Or you can write this as uxy minus z is equal to 0. The surface equation is always given by a function of x, y, z. Okay. Function of x, y, z. So this PDE given implies that these two are normal. The ABC is a dot product with the normal vector is. That means what? That means this vector is tangent. ABC vector is tangent. Tangent vector. Of course, everything at a fixed point, okay? Tangent vector to the surface. Okay. So, what is actually tangent vector passing through a point, tangent line passing through a point in a curve? for a given curve, that is x prime t, if the curve is given by this parameterization. Okay, if the curve is xt, yt, zt. Okay, if this is a curve, then x prime t, y prime t, z prime t is a general tangent vector. So these are proportional. Yes, and what you are saying is correct. Dx upon, we also can write, this is the cross ratios, right? This is equal to dy upon b is equal to dz upon c. Actually, we should write like this. Okay, what you are saying is correct. They are proportional. That is dx and upon a. These are called cross ratios. But we can write also as a in the equations, right? These are we can write it as dx upon dt is equal to a, dy upon dt is equal to b, dz upon dt is equal to c. Okay, for fixed point. So that's how we obtain we solve these each of these system of equations to get the characteristic curves. Okay. Now come back to the second point that is given to us. P is any point given to the, and third is chi is what is the third thing given? Please see the problem statement. Third thing is given to us is contains the characteristic. Yeah, chi is a characteristic curve. Is a characteristic curve. And these three are given to us. Now, to prove that chi belongs to the surface, chi belongs to the surface. To prove that chi belongs to the surface, the given surface. So how to prove that? Chi we are defining like this. So that means chi satisfies the curve is like this. Curve xt, yt, zt. That means curve belongs to the surface means what? That means this should satisfy the this should satisfy the surface equation. That is to prove z t is equal to u of xt yt. Okay, to prove that zt is equal to u of xt yt. Now the proof. How to prove that? Now call now define phi of t is equal to zt minus u of xt yt. Okay. So what is now phi t is this one. What will be phi prime t? Differentiate this one. Phi prime t. Phi prime t will be z prime t minus. This is a composition, so derivative and x prime t minus uy into y prime t. But this curve, this is characteristic curve. Third thing given to us is that chi is a characteristic curve. What is the meaning of characteristic curve? Characteristic curve means it is obtained by solving dx by dt is equal to a, dy by dt is equal to b, dz by dt is equal to c. The meaning of characteristic curve is that it is obtained by solving this system of equations. So that means x prime t is equal to a, y prime t is equal to b, z prime. So this is c minus ux into a minus uy into b. Okay, but this is our actually this ABC is a vector field given to us, and it is, that means it is satisfying the surface given PDE. So this is equal to 0 by given PDE. So phi prime t is becoming 0. That implies phi t is a constant function. Constant function. Now, if we prove that it is just 0 at one point, then it is the entire identically 0. That's what we want to prove. We want to prove that if we define like this, to prove this is equal to this, we have to prove that phi t is identically 0. That's what we are looking at. Phi prime t first, it became 0, so it is a constant function. And look at what is phi at t naught. Phi at t naught. What is t naught? T naught is a point. T naught is a point. Sorry. Yeah, x. Yeah, correct. X naught. P is the given point. X naught, Y naught, Z naught in the surface. And yeah, P is a point, and chi is the curve passing through this thing. So always remember that given this is a parameterization, some interval will be there, alpha, beta, and we will have a map, and T naught is any point here. So to this point will be x naught, y naught, z naught. That means this is x of t naught, y of t naught, and z of t naught. Our p is point x naught, y naught, z naught. That means correspondingly we'll have a t naught where this is parameterized to this thing. So phi at t naught nothing but x at t naught, y at t naught, z at phi at t naught is nothing but z at t naught minus u at x at t naught, y at t naught. Okay, but this point, what is the given statement that chi belongs to? Sorry, this point P belongs to second given thing is given point in the integral surface. P is a point given in the integral surface, and so, and also P passes through the point curve. So this is equal to 0. So phi at t naught is 0. So phi at t is a constant function. It has to be identically. Okay. So what is this entire thing saying? Entire thing, what it is saying is, if you take any curve, if you take an integral surface, that means it is a solution surface to the given PDE. And if you take any point and a curve passing through, characteristic curve passing through this point, it has to entirely lie inside the surface, integral surface. One way it is, the definition of integral surface is nothing but it is composition of all the sum total of all the characters. The other way around we are saying. What is the other way around? If you take an integral surface and take any point and a curve passing through, characteristic curve passing through, it has to entirely lie in the integral surface. That's what this problem is saying. Okay. So next is, shall we go to the problem 2? Problem 2. So what is problem 2? Read out. If S1, S2 are two graphs, that is, what is the meaning of two graphs? That means they are the surfaces. S1 is a surface equation. S1 is the surface equation U1 xy. S2 is another surface U2 xy. Okay, these both are S1, S2 are integral surfaces. Given that S1, S2 are integral surfaces, integral surface of what? Integral surfaces of a vector field V. Okay, and they intersect in a curve. First thing given to us is this one. Second is S1 intersection S2, two surfaces. Intersection is always a curve, and let us call that curve as chi. Okay, call this as chi. Now prove that chi is characteristic. Okay, so to prove that chi is a characteristic, that means intersection of if there are two surfaces, there can be infinitely many integral surfaces. Okay, the solutions need not be one integral surface, because these are general solutions. So if you take any two integral surfaces, then their intersection is always a characteristic curve. That is the conclusion of this. Prove that chi is characteristic. Okay, so we have to use we are going to use this use problem 1. Use problem 1 to prove this. Okay, so what I will do is to use what is the conclusion of problem 1? What is conclusion of problem 1? That if we have an integral surface, and if we take any point, integral surface, take any point P and a characteristic curve, it will be entirely inside this one. So I will do, I will take S1 and take a point and take the entirely, I will say that chi belongs to this one, and similarly I will do for the S2 also the same thing, and apply so sorry, apply problem 1 to S1 integral surface and S2 integral surface. What we are indirectly saying is if at all there is a what indirectly what we are saying is that start with any characteristic curve. Okay. Start with any characters. Let us call maybe this one as yeah, chi itself. Start with any characteristic of chi. Okay. Chi characteristic of passing through a point P. And apply now this is a characteristic curve passing through a point P. Apply this to apply problem 1 to S1. From this, what we can conclude applying problem 1, that chi is entirely sitting inside S1. By problem 1, we have that chi is, the conclusion of problem 1 gives us that chi is, if it is characteristic, it has to be entirely inside S1. And also apply the same thing. This is an integral surface, and here it is, yeah. And now this is a characteristic of passing through the point. So again, apply problem 1 to S2. That implies, because it is the same integral sorry, the vector field is same. Vector field is same, and S1 is also an integral surface to V. S2 is also an integral surface to V. Okay, so I am starting with a characteristic curve. So applying this problem 2, then we have chi is entirely sitting inside S2. So chi is inside entirely in S1 also, in S2 also. So chi is in the intersection. Okay. So from this, what we can conclude is that any curve, indirectly we are saying that any curve that is intersection of S1 and S2 has to be characteristic. If at all there is a characteristic curve, it has to be entirely inside, it has to be in the intersection of S. Okay. So that concludes that any two conclusion is that any two integral surfaces intersect to produce a characteristic curve. Okay, any two integral surfaces intersect to produce a characteristic curve. So indirectly we proved that. Take any characteristic curve, it has to be in the intersection. So that is the. Now come to problem 3. Okay. So always now come to the problems with the initial data curve. Initial data curve. What was method of characteristics? Method of characteristics was gamma initial curve is given to us, something like f of s, g of s, and phi of s, or h of s. H of s. Okay, s initial data curve gamma is given to us. What is method of characteristics? Method of characteristics is based on how it works. So gamma is given to us. This is the initial data curve. This is given to us. So what we are doing is, this is Fs, Gs, Hs. Okay. Take any S and fix any S and draw a characteristic curve. fix another S, draw a characteristic curve. Like that, based on this initial data curve, we are drawing the characteristic curves and we produce this integral surface or solution surface. Okay. So what is the what is the all this is this gamma which is given to us is non-characteristic. It should not be characteristic. The assumption that gamma is a non-characteristic. It is not one of these. It is not one of these characteristic curves. With the assumption that gamma is non-characteristic, we are method of characteristic is working. Suppose gamma itself is the initial data itself given is characteristic. That is what the problem 3 says. If this is itself is characteristic curve, if gamma is characteristic, what happens? Then instead of getting, when it is non-characteristic, we are getting a unique type of solution. When it is characteristic, what will happen? When this is characteristic curve, that is, this is our gamma initial curve. Then what to do is take this gamma, small gamma, which intersects this at a point. Okay. And now this will be non-characteristic. And produce a solution, integral surface. Okay. U, Z is equal to UXY. Produce an integral surface using this gamma. Like that, take various various points of intersection. So for every point of intersection, you can get a gamma and produce the surfaces. So for any point, so for there are infinitely many curves, small gammas. So for each gamma, you have a solution set. So there are infinitely many solutions for this type of. So when the conclusion of problem 3 is whenever gamma is characteristic, initial curve is characteristic, we get infinitely many solutions. That is the conclusion of problem 3. Okay. So as I mentioned in the previous class that problem 1, 2, 3 are like this theoretical type. 4, 5, 6 are like formula based. We can solve them. Please you can do the 4, 5, 6, and if you have any doubts you can ask me. And if you see problem 7, 8, 9, come to problem 7, 8, 9. As I mentioned that there is a method of Lagrange's which is not method of characteristics. Like if you are given a general PDE, how to produce a general solution, that is through. Now come to problem 7. There are 3 parts. First A part, if you take, we have x plus u, ux plus y plus u, uy is equal to 0. Okay. Again, just solve this. Solve our general solution. General solution. No initial condition is given. When initial condition is given, we will use the method of characteristics to get integral surface. Now we are asked to find a general solution by method of Lagrange's. So if you see the 7 problem, so how to go about it? So no, here what is the step 1? Step 1 is first find if a surface is equal to constant, a level surface, such that it is an integral surface of the given vector field. Okay, such that it is an integral surface of V vector field. Here the vector field is x plus z, y plus z, and c part is 0. Okay, how to find what is the that is the meaning is that what is the meaning of this? That is the that is whatever we are finding. This is ABC. A times phi x plus b times phi y plus c times phi z should be equal to is equal to a 0. That is this is satisfied. Okay, well, how to find this? So we will not use any characteristic parametric parameterization and all. We will write the common ratios like this: dx upon x plus z, dy y plus z is equal to dz upon 0. So first take the last expression, that is this expression. From this expression, what we can find is z is equal. From this, what we can conclude is that z is equal to constant. Okay, so take phi xyz is z itself. And now step 2 is find another level surface, psi xyz is equal to constant c2. Let us call this constant as c1 and this as c2, which is independent of phi. Okay, so how to find? Just take come to these two expressions. Take these two expressions and integrate both sides. Integrating both sides, dx upon x plus z is equal to dy upon y plus z. This implies integrating both sides. We have ln mod x plus z is equal to ln mod y plus z is equal to plus ln c, some constant. But z is equal to constant c1 is c2. So from here, what we can conclude is that this implies that x plus we can get rid of the ln's. C1 is equal to y plus C1 into C2. This implies x plus C1 plus C1 is equal to C2. So this is our another psi. Take psi is equal to xyz is equal to x plus z upon y plus z. Take psi. Now write the general solution. Step 3. Write the general solution is phi is equal to the function of psi. Okay, that is z is equal to function of x plus u, y plus u. F is an arbitrary function. Okay, so there are infinitely many solutions. Any arbitrary function of this is a general solution. So this is the method of Lagrange, how we find the general solutions. Okay. So please complete the B part 7B and go through 7B and 7C. Okay. Now coming, what are the other? What is other problems left? Now the same thing. 8 is on. Yeah. Any questions, please? So in tomorrow's class, I will discuss problems 8 and 9 tomorrow. So so we have decided that we will have 4 tests. So test 1 we have to have soon. Once we complete these 3 exercise sheets and also the general nonlinear situation, we'll have test 1. So date we have to decide. Date for test 1. So this week we will complete the syllabus for test 1. So this week is so shall we have Saturday or 27th? Or Monday? So we have to decide about this. So 24 hours, 25 marks, test 1 on the syllabus that we have completed now. Completed means the entire first order PD. Monday is fine. Okay, Monday is, if you, for everyone Monday is fine, then we can, so that you can prepare on Saturday, Sunday, Monday. Yeah. Okay. Avadesh is Monday. Yeah. Yeah. So I will take a survey also. If anybody has for no further extension, please let us complete on Monday itself. So the early the better, before other test comes. So yeah, that's it for today. Tomorrow we'll discuss problem 8 and 9, and then go to the sheet 2 and sheet 3. Thank you.